This question is find the current passing through resistance R1, R2, and R3. So to solve this, we can use the Kirchhoff current law. First, we need to assign the unknown node. Let's assume that this node is node A, and this is our node B. Okay, so we have a current go into this junction node A, split into this part. Let's assume this part is I1, and here is I2. And then at node B, we have this I2 here, and go out from this is I3. Okay, so now we can write the Kirchhoff current law at node A. Okay, so at node A, we have 4 currents, which is the current source 6 ampere is going into the junction node. So 6 ampere must be equal to 3 current coming out, including this 3 ampere. So we have this I1 plus I2 plus 3 ampere, right? So for this, we have I1 plus I2 must be equal to 3. Now we going to use the Ohm's law to substitute this I1. So I1 is equivalent to this VA minus 0 divided by R1. So we have this VA divided by R1, and I2 is a VA minus BV and divided by R3, and this must be equal to 3 ampere. Okay. Right, so in this case, we're going to substitute R1 and R2 value. So in this case, we have this VA R1, so we have 8 ohm, and then VA minus VB, and R3 is 4 ohms equal to 13. Okay, now we can simplify this. After we simplify this, we get 3 VA minus 2BV equal to 24. Okay, so that is the equation number 1 that we get from node A. Now we find the Kirchhoff current law at node B. If we refer to this junction node here, we have 3 currents, okay, at junction node B. So 2 currents are going in, which is I2 are going through the junction node B, plus the 3 ampere current source, and only have 1 current coming out, which is I3. Okay, so I2 is equal to VA minus BV, then divided by R3 plus 3 equal to I3 is the BV divided by R2. Okay, so we're going to substitute the value for this. We have this VA minus VV. So R3 in our case is 4 ohm plus 3, and VV and R2, which is 6 ohm. Okay, 6 ohm here. Right, so we're going to simplify this. In this case, then you will get 6 VA minus 10 BV equal to minus 72. Okay, so in this case, we have these 2 equations, equation 1 and equation 2. We have 2 equation 2 unknown. We can find what is the VA and VV, right? So there's no problem for this. Let's assume that we're going to multiply this equations 1. Okay, this equation 1, we're going to multiply it by 2. So that case, we have 3 VA minus 4 BB is 48, right? So from this, we can minus this. So after this, we're going to minus our equation 2. So we bring down this equation 2 over here. Then we have this 6. We have this 6 VA. Okay, 6 VA minus 10 BV equal to minus 72. Okay, so we do these calculations. We get 6 VV equal to 120. So our VV is equal to 20 volt. So if we find the VV, then we can find what is VA by substitute into equation 2. So from this, you may find that your VA is 21.33 volt. Okay, so you have the VA and VV, right? So you have VA, VV, then you can find what is the current passing through R1, R2, and R3 just by substitute the value. So for current through resistor R1, Okay, resistor R1, this is equal to the VA divided by R1 resistance value, which is 8 ohm. So VA is what? Is 21.33 divided by 8. Then you get the current for this is 2.667 ampere. And then you find the currents for through resistor R2. Okay, resistor R2 is 6 ohm here, which is VV, which is the VV divided by 6 ohm. So in this case, we have VB is 20 volt divided by 6. Then we get 3.33 ampere. And then the current passing through resistor R3, which is in this case here, R3 here, which is the VA minus VB divided by R3. Okay, VA minus VB divided by R3. So we have this VA minus VB divided by R3. So VA, we have 21.33 minus 20 divided by R3. R3 is 4 ohm, right? So R3 is 4 ohm divided by 4. So that means you will get 0.333 ampere. Okay, so that is the current flowing through R1, R2, and R3.